Hello everyone, my name is Jennifer Marsman, and this crazy contraption you see on my head is a headset that reads EEG. So what I am doing, about 6 years ago, I want to say, in 2010, I saw a TED Talk by a woman by the name of Tan Lee. And she created a headset that reads your EEG and showed some of the amazing things that are possible with it. And you guys, I have just lusted after this headset so badly. I've wanted one for years and years, and finally broke down and got one, and had all these crazy experiments in my head of like things that I could do with it. And so the one I decided to tackle first is the problem of lie detection. So I started thinking, I got this headset and I put it on my husband and I asked him a series of questions. And first, I told him to tell me the truth to all the questions. Then I had him lie to me. And as you guys know, what that gave me is a labeled data set of here's what your EEG looks like when you're telling the truth, here's what it looks like when you're lying. Then I used that to build a classifier to perform lie detection. So that's what we're going to talk about today. A couple of background things. So I do work for Microsoft. This device is not made by Microsoft, so let me be really clear about this. It's made by a company called Emotiv. The one that I'm wearing is called the EPOC Plus, and it's a female-founded company. Woohoo! And so it's a really cool headset. I can talk to you about it afterwards if you're interested in more information about it. And then I will say I have held a number of machine learning roles at Microsoft, but I am not on the Azure ML team right now. And I am not in I'm not in the CNTK. I've used a lot of these tools, and so I can answer questions about them, but I just want to make it really clear I'm not on those teams either, just so you have a sense of what I do. Okay, so let's talk a little bit. So first of all, what is EEG? Just to kind of lay out the definitions up front. So EEG are essentially your brain waves. It's those electrochemical signals that are running through your mind that we can use to measure how your brain is functioning. And so I started thinking when I was trying to figure out, what cool things would I want to do with this headset. And my graduate studies were in machine learning, and so I had taken some of the kind of neuroscience type classes, like studying the brain and how we could try to emulate it with machine learning. And I started thinking about how when we tell the truth, that activates the recall centers in our brain, right? And when we lie, that activates the creative centers in our brain. So I started thinking, it seems like that should be possible, right? To be able to use EEG, and when you look at this crazy thing on my head, there's actually 14 different points that are actually touching my scalp right now. And so if those centers are in different areas of the screen, maybe they would light up differently. So that kind of became the fun machine learning problem that I wanted to try to solve. I will also say that this is a work in progress. So I'm going to share with you kind of my journey thus far, some of the things that I'm trying, but it's not complete yet. So I hope to continue to be speaking about this for a little bit and sharing further results as it comes out. But hopefully it should be fun what we've got so far. All right, so that's that. And then I do have a blog and I'm on Twitter and all that. So if you have questions afterwards, and I'm going to be here till the very end of the day. So feel free to grab me. I'm happy to talk your ear off about this research. But if you don't get a chance, feel free to reach out to me however you're most comfortable afterwards. All right, so before we start, I just kind of want to give you a sense of the power of this headset and some of the things that we can do, because it's kind of fun. So let me just jump into a quick demo. I'm going to show you a piece of proprietary software that actually came with this headset, just so you can see some of the challenges that we experience with working with EEG data. First of all, the first thing I want to show you is that, actually, let me throw open Test Bench too to show you this. We'll go back to that in a second. But here's some of the things that it can pick up. So first of all, one of the things that they surfaced to you, and this is available through the developer SDK if you want to play with it yourself, is, and did you see me look back and forth? Look over this way? Look over that way? Is it doing it? I can't see because I'm not actually looking. Looking that way. So it does that. It blinks, blink, blink. Oh, that's not right. I'm sorry. Were you guys looking at that the whole time? No wonder you're like, what is she doing? Blinking randomly up there. So what this does is it can detect several facial expressions. What is going on? Hello? So it's detecting several facial expressions. So if I look one way, oh, the signal strength is issues. Okay, so this sometimes happens. Don't worry, we're gonna get past this. Whoa, that's not good. All right, so sometimes, so what it's using is a proprietary wireless format to transmit. This has, the other side of this is plugged into a dongle right here on my machine. So it's moving back and forth. And sometimes when there's heavy interference from things, like a microphone, it can cause a little bit of issues. So we'll see what we can do here. No. Okay, let me try to jump to this demo because this is the more fun one. Let's see if we can get this done with the microphone. I'm not feeling good about this. Can we do it? Can we do it? Oh, I'm so plugged into so many things right here. I don't know that that's possible. Try. I can't get too far out of range of this because it has to go to the dongle, but let's try it like this and see what we got. It seems to be doing okay right now, just a little bit further away. Okay, so what I want to do first, let me show you this one thing. This is one of the things that made me fall in love with this device. And this is a really cool example of when we're thinking about artificial intelligence, think about how the very, very earliest things that we experienced were just pattern matching, right? It wasn't, true proper ML. It was just something as simple as pattern matching. So think of Eliza and how amazing Eliza was. For those of you who are not familiar, Eliza was essentially a chat bot of sorts before chatbots, where it emulated a Rogerian therapist. So that style of psychology is one in which you basically answer every single question with another question. Like, oh, I hate my mother. My mother is always stifling me. Why do you think your mother is always stifling you? So it's really easy pattern matching because basically you just take whatever they asked you and turn it around and turn it into another question to feed, ask more stuff. So it's a very easy thing to emulate in a chatbot, but people would pour their hearts out to Eliza and tell her all of this personal information and really she was a real therapist. And some people they'd come in, okay, the study's over, and they'd be like, no, hold on, I have some more stuff to get out. And so Eliza was famous for being one of the first things to pass the Turing test, where people really didn't know the difference between a machine and another human. So you can see we do have a lot of power and a lot of cool things we can do just with pattern matching, and that's essentially what this is. Or not. All right, here we go. Let's try this. All right, so what I'm going to try to do from here is I'm going to try to train this to basically do pattern matching to move a cube with my mind. So I'm going to start by just getting a sense for my neutral brain state. So I'm going to train this for 8 seconds. So I'm going to close my eyes. There's going to be an awkward silence, but we're all going to be okay with that. I'm going to close my eyes and just kind of go to my happy place, and then that's going to get what my brain is like at rest. So here we go, 8 seconds. Okay, you guys can yell when it's over since my eyes are closed. That's okay. It's okay to yell out at that point. All right, so I'm going to go with a yes, and hopefully it didn't go. It's still on the screen, so it looks like it didn't take. All right, so now what I'm going to do is I'm going to visualize pull in my mind for the next 8 seconds to try to get that. So there's a lot of different things you can actually make the cube do. I like pull because it's a nice visual, because then you see it coming towards you and it looks pretty cool. So let me do pull, and now I'm going to think pull in my mind, or actually one long pull for the next 8 seconds. All right, here we go. Okay, so now it's basically, this is what Jennifer's mind looks like at rest, so you can normalize the data across all people. And here's what my mind looks like when I'm thinking pull. All right, so now the cube is live. So we're gonna watch it hover there for a second, update the cube, and now I'm gonna think pull. Right? We're gonna keep doing it. I'm sorry, I'm just going to do this for the rest of the talk. I hope everybody's okay with that. And I lost it just in time. Yay! Great software. It managed just in time. Okay, so I'm gonna come back to that because that's a little getting crazy right now. So we'll come back to these things. But you can see some of the power of what we can do and some of the things that we can do with EEG. So something as easy as that, very cool. So I was able to move a virtual object with my mind. So that's really cool, and that might be really neat for things like gaming and stuff, but think about the real-life applications that we could do with this, right? One of the examples that Tan Lee gives in her TED Talk is the example of a paraplegic, someone paralyzed from the neck down, being able to move in a wheelchair, by the power of, actually it's facial movements is what they cued it on, but you could think about using thoughts and using facial movements to be able to interact with your world. So it's a very, very powerful thing. And examples like this, we're actually using technology and machine learning to help people's lives, like make their lives better. That's what really, does it for me at the end of the day. So it's very cool things. All right, so we're talking about all these wonderful, great things we could do to help humanity. And what does Jennifer choose to do with it? Yeah, lie detection on my husband. Right, exactly. So I started thinking about some of the issues that we have with current lie detections. Now, obviously, you guys probably watch all the same crime dramas that I do. So you know that you can beat a lie detector test by like stepping on a pin and something, and so you get stressed out when you lie, right? But then if when you're telling the truth to an answer, you step on a tack that you've hidden in your shoe or something like that, then it creates that same stress thing, because it's pain also creates stress as much as telling lies. And so sometimes you can beat lie detections using kind of cheats and hacks like this. So and there's people that kind of argue about how polygraphs, their effectiveness. So there's a whole bunch of research I can point to you online about all kinds of discussions about polygraphs and their effectiveness. But the traditional ways are measuring things like heart rate, galvanic skin response, your sweatiness, that sort of thing, rate of breathing, all those kind of things. And critics say that those aren't actually indicators of guilt, they're indicators of high emotion, right? You're very emotional about it, and so that's useful information. So that was kind of my end goal, and in good little former grad student fashion, I've listed out, here were my goals, here are the tools I used, all of these things. But at the end of the day, that was the idea, is can I use this EEG to be able to do lie detection? All right, so here was my initial experiment procedure, and I've actually modified this over time. And I'll talk through some of the differences that I've made and the changes I've made here. But the original experiment was I sat my husband down. I actually had him sit in a chair, and I did have him close his eyes. And the reasons for that were twofold. Number one, I was asking him questions and reading these questions, and I didn't want him reading them over my shoulder, because then I couldn't accurately pinpoint that point in time when he's like hearing the question and then formulating the response and giving the response, right? I wanted to narrow in on that time series data like as closely as I could. And so if he was reading it over my shoulder, I might get an inaccurate thing of when he was actually doing the processing and deciding to lie or tell the truth in his head. And then the other reason is because facial movement, which you may have seen from that earlier demo, but if not, I can show you in test bench right here. Facial movement actually makes a huge difference. So if I do like all kinds of crazy faces, this is going on the internet, which is fabulous. I can't tell you how many things there are of me on the internet with crazy hair making stupid faces. But these kind of things. So you can see my facial movement creates like wild deviations in this data. So because of this, EEG is really, really noisy. So I wanted to kind of try to isolate my variables as best I could. So when these initial things, I'm like, give me just, can you, don't scratch your face or anything. Don't make any crazy facial movements. Just, close your eyes, go like this and answer yes, no, those kind of things. All right. So that is a little bit of the experiment. Let me show you the markers too while I'm in test bench. That'll be fun. So I used some markers to annotate the data as well. So I would sit him down and I asked him the question. I had this tool open, and this tool allows you to make to annotate the data. And so I wanted to actually get a good sense of where he was when he was telling where I finished asking the question and when he started answering and that sort of thing. So I don't just have this huge thing of time series data. I wanted to be able to isolate out those little chunks. So I did that using this guy right here, little markers file. And so this is the earlier one where I would ask, okay, question asked, send a marker. And if I do that, boom, right now you can see a little something gets put into the data. And this data, as it goes in, so you can see it looks a lot like, it's waveforms, right? And there's actually 14 different lines right here. You can turn some channels off because it's the 14 different channels that are touching my scalp. So you can look at some of them individually if you want to and kind of isolate which ones are doing different things, if that's useful. So I have all of that data. It's all dumped into a proprietary format, but then they have a thing to convert to CSV. So I can show you what it looks like as a CSV as well. And so once it gets converted there, the data looks like this. And it's taking, the sampling rate is 128. So it's taking 128 readings per second, which works out to a reading roughly every 8 milliseconds, okay? So you can see here kind of what we have here is just a whole bunch of data. These are the 14 channels of data that it's reading, like so. So you can see the values are all roughly in the 4,000s. there is a gyroscope, which I have not used this as a feature yet, but it might actually be interesting, right? Because has anybody ever watched like the World Series of Poker? And you know how sometimes they have the tells of, you know, you tilt your head one way or the other or something like that. There might actually be some signal in there, right? It might be interesting. I don't know. I haven't played with it yet, but that's kind of an idea. And then the markers, when I do send those manually annotated markers, those show up as a 1 or whatever value I sent in this marker column. So then I use those markers to parse out, okay, here's when I asked the question, here's after you answered, so I can parse out when his brain was actually doing the thinking about my question. And then I have a timestamp. So the way the Emotiv device does it by default is they have a second value and then a millisecond value. And so I actually do some math at the end to do, you know, seconds times 1,000 plus milliseconds to get it in one value, so it's easier to do math with as one value. And then right here, this is nice too for data cleaning. They have a contact quality. And this contact quality, there's one for every sensor on my head. So as you could see, let me see if it's still orange. You might have been able to see earlier that, yeah, this one is yellow right now. So this one isn't reading completely 100% right now. So green means it's very strong signal quality. And then there's levels of progressive degradation, which I'll show you in a second. And this 4 is, this is all clean. So 4 is actually the best. So this is data that's already been cleaned and processed. But we have a contact quality for each of them. And then here's where I started adding stuff at this column. So this was all stuff I manually annotated at the end. So this is whether he was telling the truth or lying. So is truth, and I just do a 1 or a 0 based on whether this was a truth session or a lying session. And then here's my math to do the time to get it all in one number to make it easier to do math with it. And then once I started expanding beyond just my husband and trying to get data from lots of different people, I added a user ID as well. And then I have some other data I'm collecting too. So that's kind of what the data looks like. Let me also show you here some of the questions that I was asking. So I ran this thing that I showed you. I was sending those markers. I asked the questions multiple times. And the reason for that is because, as you saw with all that facial movement, the EEG is so noisy. So asking multiple times and then taking averages helps eliminate some of that noise. And then the questions I asked are all in that little right-hand sidebar right there, so you can see. And some of the correct answers to those are yes, and some of the correct answers to those are no. And that was just so I would have a nice confusion matrix of true, false, yes, no, all split up nicely. We do not have 5 children, in case you're wondering. At least I don't have 5 children. If he has 5 children, then we have a problem. There's something I don't know. But I created all these questions as easy kind of yes, no, should be fairly straightforward, one way or the other things that he shouldn't have any problem with. And so again, I had him answer yes or no, and then I asked him to do all this for truth, and then again, answer all the questions lying, and then that's how I kind of gathered my data set in the earlier one. Here's a quick picture to document for posterity my poor sainted husband tolerating this procedure. I like to show it on him because he's a little bit more follically challenged than I am. So it's a little easier to actually see the headset on the head than mine, which is like hair and stuff. And I've noticed every time like the Emotiv people do a demo, they always use a bald guy. And it's because, oh my gosh, it's so much easier when you put it on a bald guy. Bald guy, you just put it on and bam, it just works and it's awesome. Like for me, I don't know if anybody saw, I was like prepping around the corner, but like I put it on and I'm like moving chunks of hair around and trying to get the sensors against the scalp, and it's a lot more work. But this is what it looks like when it's a little easier. So you can kind of see those 14 different channels that rest against the scalp. That kind of go around the top, and then there's some underneath here as well. Oh, I love the look he's giving me right there. No, Jennifer, I don't have an Ashley Madison account. Can I please go watch TV now? No, honey, you can't. Okay, so let's talk a little bit about the quality and the data cleaning that we can do with this. So I already showed you when we got firsthand, demo of sensor quality and seeing them go from red to black and all that kind of stuff. But essentially, it's a scale of degradation of the contact signal. When I do put this on, it is a wet sensor, so it's a little felt pad, and I put just the same contact solution that I use for my contact lenses. So it's just saline solution that I put on there to get a good contact. And so when it's optimal contact quality, that gives you the green, and it's in an enumeration where green is 4, and then there's kind of progressive levels of signal degradation. And so we saw it go black for a second there when there was microphone interference. All right. The other thing is the sensor position. So you guys saw some crazy column headers when I was showing you, okay, this is the actual data in the Excel spreadsheet. Here's the positions that they actually map to on the brain. So we have like T7 and T8 are the ones directly over the ears. This O1 and O2 are the ones like in the back, right there. Okay. So now, again, like a good little grad student, I went to do some research. What are other people doing here? Usually when you have a great idea, someone has been kind of sort of thinking about it as well. So what are other people doing kind of in the fields of EEG and lie detection? And I found something similar that several government agencies are working on that was kind of cool. They're using something called the P300 ERP. So ERP stands for Event-Related Potential. It's kind of an easier way to process EEG than raw EEG, is looking at the ERP instead. But essentially what this P300 does is it measures, like recognition is probably the easiest word. It's a slight simplification, but that's somewhat akin to what it does. So think about, you're walking through MLconf and you see a face, like someone's face goes by you and you're like, oh, I know that person from somewhere. And you just get that instinctive flash of, oh, I know that, I recognize that. And that's something that your brain does instinctively. And that's called the P300 ERP. And the reason they call it the P300 ERP is because it occurs roughly 300 milliseconds after the stimuli. So you get that little dip that you see right here. So we have kind of a normal waveform, and then you see the little whoop at this it's around 300, but it's really anywhere from 250 to 500 milliseconds after the stimuli. And so the way that they're doing it in these government agencies, the tests that they're doing are, they actually show, instead of asking questions, they don't ask questions at all, they use images. So imagine, sitting down a suspect and flashing pictures in front of them. So maybe some of these pictures are just neutral pictures, but if some of them are pictures of something that only a suspect would recognize, that can be very useful. So imagine you're seeing a bunch of pictures, and then there's a picture of the crime scene, or a picture of the murder weapon, or something like that that could potentially be telling that you have more knowledge of the crime than you're letting on. And so they are using that and finding the correlations between, hey, you're recognizing something when you say you have no knowledge of this. Something's not right here. So it's a little different than what I was doing, because I'm still, asking yes/no questions and that sort of thing. But the thing that I found really interesting about this, and the most useful, is the fact that this was happening in hundreds of milliseconds. Just because when I started out, I wasn't sure, this headset samples at roughly every 8 milliseconds, as I said. And so was that enough, right? Like, as the buffer, like what time frame do these things happen? Like, would lie detection happen? Are we talking like, 3 milliseconds or whatever? And so when I saw these kind of hundreds of milliseconds, I'm like, okay, I think the sampling rate is good enough. Problem solved. So that was kind of nice. All right. So now let me talk a little bit about the tools and what I did to solve some of this. So I had all this great data. We talked about what EEG is. We talked about how I kind of gathered the data from the headset. And then we at Microsoft, one of the products we have is something called Azure Machine Learning. And it's a cloud-based machine learning set of tools where essentially you have a nice drag and drop interface. Where you can drag and drop 25 different algorithms onto a workspace and wire up a data flow, and then you can really quickly and easily like swap in and out different algorithms and tweak initial parameters. And it's almost like a really nice, like I almost want to say like a rapid application development type tool for machine learning, just because you can iterate over things so quickly. And they have other modules in there for importing data and cleaning data. And they have nice, so this is awesome, is like for the folks in this room especially, is there's modules that you can insert your own custom R and custom Python. So you can insert your own little scripts in there as well, and use other things if you'd like. So it's a neat tool. So I wanted to try that and use that to work with this problem. So that's one of the things that I started with. And then once you've created and built this model, and again, you can do it all from your browser, and they have free trials available if you want to check it out. But you can do it all in your browser, and then you basically push a button and you can deploy it. It just sends that trained model to a web service and then exposes it via REST endpoints, and you can just make calls to it. And then they give you all the sample code to call it in 3 different languages, which are C#, Python, and R. So it's really, it was nice for me to use. So I did that, and I kind of created a workflow that looks something like this. This is probably a similar thing to what other people use, for supervised learning. But a very, very simple initial setup where, okay, I get this data set, I do some kind of data cleaning on it. You might want to do aggregations, things like that. And then, of course, in machine learning, I think everyone in this room knows that we split our data when you're working with supervised learning into a training set to actually build a model, and then we hold back some data that it's never seen, so that way we have some new, fresh things to test how well that model that we built performs. So I did, 70% training data and then held back 30% to send to use as test data. And then trained it using a couple different models and different algorithms. And then you can score the model, see how well it performs, and then evaluate it against other things. And this is the other thing that's kind of nice is kind of the art of data science is let me try lots of different things and see what works well for this particular data set. And so you can actually, do this whole thing, over here as well, and then kind of pass both models in, and then it gives you some really nice comparisons and of the two models against each other, which is really nice. And I can show you that in a second. The other thing that I don't think people in this room need to know, because I know these are kind of more machine learning experts here today, but a lot of times when I'm talking to developers, they look at this list of 25 algorithms staring them in the face, and they're like, which one do I use? How do I know? And so that's where they've tried to make it easy. They did put together a machine learning cheat sheet, the algorithm cheat sheet. And this is just a nice thing if you're into ML. It's fun. It's fun to hang on your wall. It's a really nice thing because it kind of shows, okay, here's the different algorithms and here's where each of them really shines in a nice declarative way. So you kind of start in the center node and talk about, what is it that I want to do here? Do I want to find, unusual data points? So maybe I'm trying to do a case of like credit card fraud detection and I have a whole lot of valid data in a very, very small amount of like known fraudulent transactions. In that case, anomaly detection is great. There's a clustering algorithm. We support a k-means clustering algorithm as well if you want to do supervised or unsupervised learning, excuse me. And then we have a bunch of regression algorithms, a bunch of classification algorithms in there, and we support both two-class and multi-class classification. So there's a really nice kind of declarative thing where, okay, you figure out what you want to do, you go in here, and then it tells you, yes, SVMs are great if you have lots of features. Decision jungles give you a smaller memory footprint than a boosted decision tree, those kind of things. So it kind of lays it all out in a nice declarative way for you. So in case I saw some people holding phones up to take pictures, if you want to download it as a nice, high resolution PDF, you can get it from aka.ms WAC Azure Machine Learning cheat sheet. It's kind of a cool resource. And then if anyone wants to play with it and kind of kick the tires, it's been pretty cool to use, I think. I wrote a blog post on getting started with Azure Machine Learning, so you're welcome to check that out as well. And I wrote it for student audience, so forgive me, there's a little bit of spin at the beginning. It's actually titled, How to Win a Hackathon with Azure Machine Learning. But just ignore the first paragraph, and then it's just how to get started with machine learning after that. All right. So now let me show you kind of some of the early results and some of the early things that I did. Now let me be really clear. This first thing is not actually doing lie detection. What this particular thing is, I'm not doing any time series processing here. What I wanted to do is basically, can I even differentiate between two sessions? Because basically I had sat my husband down, I had asked him to do all the truth stuff, and then I had asked him to lie to me, and they were right in a row, so his mental state should have been very, very similar. And I wanted to see, okay, if I gave just all the data, can it differentiate between that? And so that's what this does. So basically I took that CSV, that was the truth data, the CSV that was the lie data, this add rows, here, let me zoom in a little bit more so you guys can see this. There's an add rows module that essentially just merges them together. Then I'm using this metadata editor to basically, so Azure Machine Learning by default treats everything as a feature. So I'm just telling it that my label column, the thing that I want to predict, is the is truth column. So I'm setting that there. And then I'm actually throwing out some columns in this project column. So that allows you to throw out some data. So things like, I don't know if you saw in the Excel spreadsheet, there was like the gyroscope and some other things that were not useful. There was some time, one that counted to 128 and then reset itself. And that wasn't useful too. So I threw out some data there and then split the data. And I believe this was a 70-30 split. Yes, 70-30. So this is the percentage I want to send to this one. So then I had a training set and a test set here. And then over here, I tried a logistic regression. So, is this data linear? In which I had a pretty good indication it wasn't, but it's always fun to see, okay, let's try regression. Let's try this. And then I did decision jungle as well. So if you look at this, and I right click, so here's the evaluate at the end. If I right click on this and hit visualize, it gives you a lot of kind of cool information about what you're doing, as you can see. So to interpret this graph, if you're not familiar, we have the true positive rate against the false positive rate. So this is essentially 50-50 random chance, monkey flipping a coin kind of deal. So you want your machine learning algorithm to perform better than 50-50 random chance in general. If your curve is under there, then you probably want to go back to the drawing board and try something else. And you can see this one was okay. Like the linear one wasn't that good. It was kind of meh right there. But if you go over here, so I should say, I'm sorry, a perfect score would look like going all the way straight up there and then all the way over there. And usually if your algorithm does do that, you messed up somewhere, right? Because real life is messy, right? And data is messy, and something that can predict, perfectly 100% of the time is usually a little bit sketchy. But anyway, so what I have here, if we look at this one, so this was the decision jungle. If we go down here and compare what's going on, you can see that gives you really nice numbers for, your true positives and your true negatives. You want those numbers to be big. Your false negatives and your false positives, you want those numbers to be small. And then it gives you your accuracy number, recall precision F1, and then the total area under the curve as well. So, and then there's some binning down here as well to kind of look at all that by scoring bins as well. So it's kind of a lot of nice data that they give you, so you can very quickly and easily just like pound out, okay, let me try this, let me try that, let me just swap in this. So it's been a really nice tool. Even for people with a data science background, you can be really, really effective, I find, with this. So it's been a lot of fun. All right, so you can see we got like 93% accuracy. So I'm like, okay, there's got to be something to this. I was able to differentiate between two sessions, one after another. There's something to this. So let's see what I can do after that. So the next thing, all right, so I had just done some of this early research. We're going to continue on the journey here. I just done some of this early research, and like the week after, we had a team offsite, and my manager actually lives in Minneapolis, which is not where I live. And so I got him together, and we actually had a camera crew on site because we record videos online a lot for our team as well. And so I grabbed the cameraman and my manager and said, "Can I do something with you? Are you okay if I ask you some questions or something? It's for some research I'm doing for this Azure Machine Learning thing." He's like, "Oh yeah, sure, that would be fine." So what I did was take his data. So I put the headset on him, and first I had him tell me the truth to a couple questions. Are you a female?
No.
Are you a male?
Yes.
Have you ever worked for Microsoft?
Yes.
Okay, you guys get the point, right? All right, so then I had him lie to me. Do you have a PhD?
Yes.
No. Do you currently have a pet?
Yes.
No, he does not. Do you have blue eyes?
Yes.
Nope. So there you go. So now we have him telling the truth. We had him lying. Okay, guys, what would you do if you had access to your manager's brainwaves? Huh? All right, here we go. Do you believe Microsoft is the best company in the world to work for?
Yes.
Am I going to get a promotion this year?
Yes.
Okay, so did you guys see that awkward little silence and that little awkward giggle that he did? Oh my gosh, so adorable. Okay, so of course, like any normal girl would do, as soon as I did that, I ran back to my hotel room and started building a classifier on his data, because why wouldn't you? I did that. I stood up a thing, exposed it as a web service, wrote some code to call it, and I wrote, you guys will have to forgive me because my UI skills are just horrible. I'm more of a back-end algorithms girl, but I threw together a quick Windows 10 app to do this. And just to refresh you, here's the questions that he asked and his answers. So when I asked my manager, "Do you believe Microsoft is the best company in the world to work for?" And he was all, "Yes." Let's see what the classifier I built says. Oh! He just got an iPhone. I'm just saying. All right, next question. Here's a really important one. Am I going to get a promotion this year? All right, drum roll, please, drum roll. Yes, with high accuracy. We'll see. Okay, so I'll let you guys know in June if that works out for me or not. I don't know yet. All right, so you can see there's some pretty cool stuff you can do, and it's fairly easy to get started. All right, so let me tell you a little bit more. Oops, yep, sorry, I was closing that out. All right, so since I've done some of the initial work, I've done a little bit more. I the initial work got a little bit of attention, and so I've been working with some data scientists, additional data scientists, and trying to refine this, and then trying to expand it besides just torturing my husband and my manager, to try to expand it to see, could I generically, predict lie detection across a wide variety of people. So I kind of have an experiment. I don't expect you to read all this, but let me just call out some of the stuff that's important that we've kind of changed to try to make this, more effective. First of all, I'm now grabbing multiple marketers. With my first data run with my husband, I just sent a marker. I would ask the question and then bam, put a marker in there, and then he would respond. And so I actually now have I put in a marker right before I start asking the question, and then right after he answers, so I can capture the whole process of I'm asking the question, he might be thinking while I'm asking the question, and then he has to actually understand what the question is, decide if he's going to tell the truth or lie, formulate the response, and then actually do the stuff that allows you to vocalize. So all of that kind of brainwaves should be encapsulated in there. I also started taking the neutral brain state recordings, and the reason for that is data normalization, right? So you saw that when the Emotiv headset, when I did the pulling the cube demo, what that did, in order for that to be effective, they had to actually record my brain at a neutral state, right? So obviously, people's brains spike differently. Like mine may spike at 24 for a particular thing, and my husband's spikes at 3. So you need to normalize that across people. That was a joke, guys. He has a PhD. He's really smart. Okay, so then the other thing I did was take more questions to get more data and just kind of be able to average more and ask more things. So I kind of did more questions in the subsequent runs. Oh, the next thing I did is I actually switched the order I was asking the questions. So at the beginning, when I was just working with my husband and my manager, I would always ask you to tell the truth first, and then I would have them lie. And I started thinking about, fatigue effect. And you have this obnoxious woman blabbering at you, asking you all these questions. And after a while, at first it's like, hey, this is kind of funny. And then you're like, okay, I'm getting bored with this. And so I didn't want the bored always to happen, correlate with lie, because that's another, right? We need to tease out those confounding factors. So I actually switch it. And for some people, I ask them to lie first. And for some people, I have them tell the truth first. So that way we should be able to average that out. And then I'm also taking some additional data about the test subject as well. Somebody suggested, I'm not sure whether this is really a relevant factor or not, but someone suggested that, you guys have heard that, and I'm not sure honestly if this is an old wives' tale or not, but the correlation between whether you're right-handed or left-handed correlates to the dominant side of your brain. So I know that's a story that kind of goes around. So I started just writing down, okay, are you right or left-handed, and capturing that data too. So I can feed it into the model. It'll see, okay, if it's relevant, the model will use it. If it's not, it will get, it won't be seen as a compelling feature. And then, a couple other things too, but just things like that to add a little more thing. And then the last thing is, so with the session data, I also need to make sure that I'm grabbing, I need it in a single session, right? Because one of the differences one of the things that could be happening is, again, it's a confounding variable where I'm asking these things, to tell me the truth right here, and then I'm asking you to lie. And even if those two things are side by side, has your mental state changed at all? Because your mental state and what your brain waves look like is actually very different. Like when I'm tired, when I'm, first thing in the morning, before I've had my coffee, after I've had my coffee. I've done this on people when they were drunk before, just to see what it would look like. So all of these things affect someone's mental state, right? And so you want to kind of normalize across that. And so I wanted to make sure it wasn't finding differences just because of session, type variables. So the last version of the data run that I've done, I'm trying to mix a truth and lie in a single session. So I'll have them, answer questions and, all right, tell me the truth, now lie, now truth. And so it's all kind of mixed into one as well. All right, so now let's talk about some of the kind of fun under the covers stuff that I'm playing with to try to get the best results here. One way, so this is obviously time series data, right? And so when you think about it, it's actually a great thing for a deep learning problem, because when you see those waveforms, it's a lot like speech recognition, right? It's very similar. You've got these waveforms that you're dealing with. You're trying to tease out, from this group, it's, this is a particular, word or a particular sound. What I'm trying to do, okay, is this truth or lie kind of thing from a waveform. So there's a couple different ways we can do it. Unrolling the waveform basically means, okay, so here's what the data look like, and then let me take the next thing, and the next thing, and the next thing, and then you have to kind of match up the moment of stimuli and compare those against each other. So that's one way you can do it. Wavelets are also a very powerful way when you're working with these kind of signals. in frequency bands. You can divide them into frequency bands. And when you look at actually the Kaggle, there was a Kaggle challenge on EEG. Does everyone in the room know Kaggle? Yay, Kaggle? All right, cool. Kaggle's awesome. If you're not, go to Kaggle, Kaggle, Kaggle. Go to that site. It's a great site. It's great for learning machine learning. It gives you a whole bunch of well-defined problems to solve and data sets to solve them with. So very cool stuff. So you can go there and they had an EEG challenge. And one of the things that was most telling there was actually this low frequency domain signal. So that was kind of cool. There's also some great Python EEG libraries out there. There's a PyEEG. There's NumPython, I can't pronounce it. It's MNE Python, which is another EEG library. So I'm looking at those and some of the signals they've been extracting out of there to kind of get some relevant signals as well. I was also thinking around state machines and like Markov type things, because when you think about the whole process of everything, so I hear the question, I'm processing the question, I'm deciding to tell truth or lie, I'm actually doing it, like those kind of things, like that's kind of a little mini state machine. So I was thinking along those lines as well and brainstorming with that. And then comparing the data against a neutral, so doing data normalization properly. Another idea is, working with the ERP as opposed to raw EEG, which is what most people who are processing EEG do as well. So I'm doing work around that. And then, of course, ensembling a lot of these different things together. If you look at, that's the way to go. A lot of times you can get a more powerful result when you're working with, you use different data models and different algorithms for different parts of the signal, and then combine them together at the end. You can get a very, very powerful results. All right, so those are just some of the ideas and some of the things I'm doing right now in my work. And I'm happy to hear ideas from anyone else as well for thoughts that you guys have from all the other brilliant machine learning folks in the room. All right, so the next steps on this work, actually the hardest part of this is honestly data collection. I'm kind of doing this as a side project, and so I want to get a lot of data, and so I'm working on that, and just getting all the data is the hardest thing. And then as I showed you on the previous slide, I'm experimenting with a lot of different features for the accuracy, and then getting it working in real time is not hard. That's actually easy to do, but I just need to do it. All right, and thank you. A lot of people have helped contribute to this work. So great headset, awesome. Machine learning, awesome. Watch out, mind control is next. Thank you guys so much.